All right, so last class today. So nicely done. It's been totally awesome having all of you as students. This has been a really fun class. Some of you I had in 250 last year and or 270, and then the whole sequence this year. It's been really good, and I think you're all in really good shape, and you're going to be fabulously successful if you're going to WSU or UW or staying at Clark to finish physics or whatever it is you're doing. I think programming-wise, problem-solving-wise, you're all in really good shape. So that's been really cool for me. So my plan today was just to kind of talk about some C++, just because it's another object-oriented language. But obviously before we do that, if there's any questions, anything you want to go over, concerns about the exam, etc., let me know. Otherwise I'll just kind of launch into stuff. Through various circumstances, it turns out I'm going to be giving a short talk this afternoon in the ECS club on Git. So if anybody wants a refresher on using Git, or if you haven't gotten onto the Git bus yet, I'll be doing that at 12 in room 126, or 12:05 or something. Probably about a 20-25 minute talk, nothing formal.
How long do we have before you wipe everything off?
About 12 hours, no. Probably August I'll reset the server. So you've got the rest of June and July, right?
Have to do a whole bunch of pseudo.
Pretty safely, yeah.
Are the rogue scores being right?
No, I'll save the rogue scores.
Yes.
Yes, because we got to raise the bar next year, you know. So if you want to pull your stuff down from the server to keep it, right? I mean, your easiest option probably is just go into your home directory and just do a tar. Just tar cvf archive.tar dot, and it'll take everything you've got from your home directory on down, throw it into one file, and then you can just pull that down with WinSCP or SFTP or whatever. And then you're good to go, and you can untar that on another machine and reproduce your whole directory structure. So, and usually I try to make a backup of everything before I wipe, and I stick it on GitLab in a private repository. So if it turns out, you know, you're missing some incredible piece of code that you just need to get back, right, you can always let me know and I might be able to find it. So. Anything else? All right. Oh, and I mentioned this yesterday. Anybody here ever use the Rockstar Programming language? So this was started as a joke by some people, but it's caught on, and it's a full-blown programming language where most of your programs end up sounding like 1980s rock music. So I stumbled across this, and I looked at the spec, and it kind of like blew my brain, and I spent about the next 7 or 8 hours just like writing Rockstar code. So this is my version of a prime number generator. I'm not trying to be Star Wars here, I just overzoomed. There you go. So that's a prime number generator, and it's a fully Turing complete programming language.
Give back my heart. Wait, my heart was fire. Yours was ice.
I mean, this is like, you know, Poison or Winger or something. It's like.
Can we have like a video of you jamming to?
Yeah, I could perform this.
Oh, yes.
It sounds like one of those rock
That's your
songs.
final
Especially with your hearing.
Yeah.
It's like one of those rock songs that was written by like an Italian guy, but he just gave the lyrics.
Right.
It doesn't quite make sense.
Yeah.
Why can I read this?
To make it better, though, you can bring in a picture of your team.
Yeah, I can do that. So yeah, put my heart without yours into this bottle. Heart is a variable, yours is a variable, bottle is a variable, so take heart, subtract yours, set bottle equal to that. build my suffering up as an increment, so increment suffering twice, so that adds 2. And until my heart is true, my heart is a Boolean condition, right? So that's a loop. The indenting specifies the level of nesting. Put my suffering over my pain into this needle, so needle equals suffering over pain. So that's x equals a over b, so we're dividing, right? And if pain is stronger than this needle, so if that's greater than that, then whisper my suffering. Whisper is a print statement. So that prints out suffering, which is the latest prime, and then break it down as a break from that loop, so it goes back to the next number, and so on. So you can go on Git and you can find a repository called Rockstar, and it specs out the whole language, and people have written converters from this to JavaScript or Java interpreters or things like that. And
So you have to sit here and learn all of these variables?
Where did you,
I made up these variables.
where did you declare the variables?
You don't have to declare
You have to
them.
declare
It's
them.
rock and roll.
It's the
You
wild
had to learn
west.
print statements.
Yeah,
Oh,
yeah.
Why did we not make our final project in this?
I know it
Right?
would have been
but
nice.
We all had to like perform that.
I know, yeah.
Surprise PA6.
Hey,
That's really what the final is.
Yeah.
And the best part is comments. The use of comments is strongly discouraged.
This is rock and roll. It's up to the audience.
Rockstar developers are not into that whole brevity thing.
Good Lord.
What is the significance of the value 14487?
What is what?
It says Tommy was a lean, mean wrecking machine. Initializes Tommy with the value 14.
So if you want to use constants, right, you can say was, and then whatever comes after it, the number of letters in each word corresponds to a digit.
Oh.
So A is 1 and A is 4, so you can represent any numeric constant you want.
Mean wrecking machine.
God.
There's a word greater than 10.
I think I'm gonna switch my major to music.
Yeah, maybe you already
This
have.
is where you find art.
I know.
You can
Yeah.
start plugging lyrics into this and figure out what they do.
Can I write all
Yeah, there's interpreters for this actually.
Rock songs.
So yeah, you could take actual rock songs and
They
see
don't
how
make
they
sense as
interpret.
songs.
Look
You
up
play
like
them as a
rock music
code.
and see what they mean in
Right.
Is it-
Yeah, so there's some projects to work on if you want. You can make a Rockstar interpreter.
Open up the limit.
And then you can practice writing Rockstar.
pilot? Yeah.
So there's a Java interpreter that I actually downloaded, but I haven't gotten it running. But it's all lexical processing. It's parsing, right? So there's a language spec, and it tells you a few things like what are the ways that you can specify truth or false, right? What are the ways that you can specify a loop, and so on. And then a lot of this is just very elaborate variable names. But it's really just sort of matching syntax. So there's lots of regular expressions. There's interpreters based on Lex and Yak and some of these other tools that do lexical analysis. And just build an interpreter around it. Or try to convert it into C or something so it actually compiles, and that's usually harder. So I haven't actually run this through an interpreter to see if it works, but it should.
So funny. You have to perform that.
Yeah. I'll do it at graduation.
Is that your way to get us into graduation?
That's how I'll get you to graduation, yeah. All right, so C++ is also another language, kind of like Rockstar, but different.
Not as
So C++ was designed to be C with objects. I'm going to invent C++. Actually, I invented it last night, C++. So it only has a print statement, it doesn't understand percents, and it has int I equals 0. And that's the whole language. So, yeah. So C++, C with objects, right? So you can write C code and pretty much compile it with a C++ compiler. But it's basically a superset, and so the GNU C++ compiler is G++, so G++ -O, etc., etc. And sometimes you use the extension CPP for C++, but I just use C. So here's hello world in C++. So our include is IO stream, okay, which gives us access to this thing called standard : C out. And if we want to send something to standard out, we just say standard C out less than, and the thing we want to send to it, which is a little more comfortable than printf, etc., etc. So, you know, plying off the idea of redirection of input and output from Unix.
Like using namespace at std.
So we can compile with G++, and then we can run it, and it gives you the output.
Nice.
We can also say using namespace std, and this is kind of like an import statement, right? If we don't import scanner, we can say java.util.scanner sc equals, right? But using namespace says that if you don't recognize something, see if it comes from std. So now instead of std : C out, we can just say C out less than some string, and it will print that out. All right, so that works. And you can concatenate by just stringing together a bunch of less thans. And there's also this symbol ENDL, which is end line. If you don't want to write \n, you can use ENDL. Yeah.
So can you still do like header files or?
Yeah, you can still include header files.
And make files?
Yeah, yeah. Make files work with everything, right? You could put a make file around Rockstar if you wanted. And yeah, you can include anything you want. So if you make your own header file, you can use a regular number sign include.
So you said using, like the keyword, that's
Mhm.
kind of like import.
It's like import,
So
yeah.
how does include and using differ?
So include is actually pulling in source code from somewhere
Okay.
and putting that into your source
Okay.
file. Using is saying if you don't know where this thing comes from, see if it's in std, right? And you can have multiple usings and it'll search in those areas. Same thing with import, right? If you don't have a scanner defined, see if it's in java.util, right? Or java.io or java.net.
So it would be using like string, or it would be hashtag include?
To do which?
Like when we would do like a string dot. I don't know.
So like if you were making a linked list and you wanted to have a node.h that defines your node structure or something, that would be an include, right? Using is really just an abbreviation. It's saying instead of C out, instead of std : C out, I just mean C out.
It's kind of like a type def.
It's kind of like a type def, yeah. Whereas include is actually saying I want you to open this file, find the code in there, and include it in my file at this point. So that's pulling in all of the code. If I don't use anything from the std namespace, then that using statement has no effect, right? Or if I were to actually come down here and explicitly say, right, everywhere, then that using is a no op. But the include is always pulling in code and popping it into your file, whether you need it or not. So we can put multiple things on one line by just concatenating them one after another like this, and we also have this end line, which is the same as \n. Alright, so there's cool and a new line, and haha, and another new line. Alright, so another nice thing about C++ is we have actual strings. So we don't have to do character arrays with null terminators and all that. So I'm including the string library, and we don't have to put .h on these either. So I'm including the string library, and now I can say string x comma y. Right, and those are bona fide strings. And I can initialize x to hello, and I can set y equal to x, so now y is hello, and then I can change x to be equal to by, and they just act like another data type. So this would output x, which is by, and then y, which is hello. it's also got some things that might be kind of weird, but that other languages do also. We can do this in Python. I imagine if you do this every day, you find lots of reasons to use it. I don't do this every day, so I have a hard time coming up with a real reason to use it. But x, y, and z are integers. X equals parentheses, y equals 12, z equals 3, y plus 1. This is just kind of, it's a thing. What did I say? X equals. So what's going to happen? Well, since I'm saying y equals 12, y is going to get set equal to 12. Comma, z equals 1, z is going to set equal to 1. Comma, y plus 1, I'm not doing an assignment, but y plus 1 is 13. This statement translates to x equals 13, but also y equals 12 and z equals 1. And then actually, this equals y plus 1. So you can put multiple assignments inside these parentheses, and each of these happen, and whatever the last expression is in those parentheses, that's the right-hand side of the equality, and that gets assigned to x in this case. So that's something we necessarily do every day, but this should set y equal to 12, z equal to 3, and then x equal to 13, which is y plus 1.
This looks cool.
It does look cool.
You said inline would do what?
ENDL? That's a backslash n. It's just different from typing quote backslash n quote. Right, so 13, 12, and 3. And if I just do x equals y equals 12, z equals 3, alright, then x is equal to 3 because the last thing on the expression was z equals 3, so that's the value of that right-hand side. Yeah?
So if you were to put an operation in your print statement, would you use like quotation marks to like suppress certain things like we used to do in C, like suppress operations?
You mean like that?
Like, you know, if we wanted to specifically write out x equals 12 plus 1 as opposed to it assigning it or it actually like doing the operation, we would use quotation marks to like suppress that operation? Still do that?
I don't know about quotation marks. Say that again.
So
Sorry.
in C, when we would like print something and we wanted it to actually print out x equals 12 plus 1, we would use like quotation marks
Right.
to suppress the operation.
Okay, yeah.
So how would you do that in,
Same thing, if you put things in double quotes, then they're just literal strings.
and then single quotes?
No, you're thinking bash. Yeah.
If I wanted to
Right.
print quotation marks in my string, would that be backslash? Same notation?
Yeah, I guess.
Backslash should work. I'm wondering if double quote works.
I think you can do triple quotes and then double quotes.
So double quote
Like
does not
Python
work.
does, with dot strings.
Let's see.
Oh yeah, no, backslash.
So backslash should always work.
Yeah.
And double quote didn't seem to do anything, which was interesting. Backslashes are magic. Backslashes are the key to my life. They're the thing that set me off on cell matrix. All right, so we can do that. So input is also a little easier. So we can say cin greater variable name, and that'll wait for us to type something. Whatever we type will get assigned to x, or whatever variable we have. And here I've got x and y are integers. I give them bogus initial values, 17 and 89. I print a prompt which says enter x, and I don't put a new line or an ENDL at the end. So this should just say enter x, and it should sit there on the same line. And then I do cin is assigned to x. And then I say enter a string and assign that to temp. I ask for y and assign that to y, and then we print out the values. And it should understand, you know, if I'm assigning to an int, it should take my digits and interpret them as an integer, and so on. So enter x, we can do 111, enter a string, hello there, haha, and so x is 111, y is 0, temp is hello there. I don't remember what I did with y. There's something funny with y. Oh, I had spaces, okay. So x is 111, string is hello, y is 2222. Okay, so x, y, and hello. So your input is space separated. So if it says enter x, I could have said 44, haha, 7. Right, and the next two inputs pick up from that. Nope. So basic input, right, pretty straightforward. More nuanced, you can get into scanf and all sorts of stuff like that. But cin greater than variable name gets you an input from standard in.
Just in order to capture a full string, you'd have to use something like fgets.
Yeah. We can also do cin greater x greater y, and specify that we want to take the next two inputs and store them in x and y. Alright, so we can do that. And if we put on one number, we can put in the next number. Same thing. So just a different way to specify inputting two things instead of putting them on separate lines. All right. If we want to be more explicit, we can convert a string to an integer. And we know that cin, if we type in 23, but we're saying greater integer variable, it'll convert it to an integer for us. If we already have a string, for example, a string buffer, which I've initialized to, haha, this is fun, and we wanted to convert that, we can use this thing called string stream. And string stream will basically take the contents of this and pretend that we typed it, right? And then send that into, in this case, an integer I. So we'll start off with buffer being just a plain old string that has nothing to do with an integer, and we'll echo that out. And now we'll input from the user, but we're going to save that as a string. And then we're going to convert it to an integer using string stream buffer, and then print out the value of I. Alright, so, I don't know, -19.
And does it take -19 as an integer or a string?
So it input -19 as a string, But then when I did string stream greater I, it stored that into I, and I is definitely an integer because it's been declared into I.
Casted it automatically first?
The purpose of string stream is like scanf. It's saying take this
okay.
string, convert it to an integer.
Right.
And it knows it's going to an integer because I declared I to be an integer. So these are all things that we do in C, right? Reading from standard in, printfs, scanfs, and so on, or scanfs, right? But in what's arguably a little less goofy way. We can also do interesting for loops. So we can read a string from the user, and then we can say for character C colon buffer, which means set C equal to each character of this string, and for each assignment do whatever's in the body of this loop. An automatic what?
Length function.
There is. And this one needs to be compiled with an extra switch.
That just says the version of C.
The version of the C compiler, yeah. Oh, but it only goes up to a space, right? I don't know if we can just do this or not.
You should be able to.
I'm pretty sure I can mix my metaphors, but I don't know if I want to do that. No. Oh, yeah, it's object oriented. I don't do a lot of C++ actually. I plan to. So yeah, so there's length methods on strings. There's also something like generics. So we can define a function called sub, takes two arguments of some type, which I'm calling var type, returns an argument of var type, and it just returns the difference of those arguments. And this keyword template says I'm going to define something with a variable type name, and I'm going to call the name of that type var type, right? This is just a placeholder, it could be anything. But the effect is when I say subtract and I specify two things to subtract, whatever type of things those are, that's what var type is. And this code is written assuming that your arguments have that type and the return value is also that type. So I have one function sub which I can call with integers, I can call with floats, I can call with characters. And whatever I call it with, right, it will try to do an x minus y operation. right? So this is something you would do if you were making a linked list, for example. When you have a node, you have to copy the data over into it, and you have to pass a data type to your add function and so on and so forth. You could use a variable type, and it's exactly the same as a generic in Java. Alright, so 5 minus 23 is minus 18, 10.23 minus 1.1 is 9.13. C minus A is double quote. Why is that? ASCII codes. So C is an ASCII code 99 and A is an ASCII code 65, and the difference of those is 34, and that's the ASCII code for a double quote. So that's a useful feature if you're generalizing your code. Alright, so classes, we can make our own classes. So here's our favorite circle class. So keyword class, followed by the name of the class, followed by curly bracket. Public and private are declared for sections of your class definition. So if I say public colon, everything after that is public. If I say private colon, everything after that is private. So I don't put it on each individual thing. So I'm making everything public. So I've got a radius and I've got an x and a y. Those are class variables, right? They're fields in here. And then I've got a setRad method, which takes a radius. And so we're saying, right, same notion of this as usual, this arrow radius equals radius. So that takes the argument, saves it in our class variable. We've got set location with x and y. We can set x and y equal to those arguments. We've got an area method that returns 2 pi r. And we've got a distance method which returns the square root of, that's how far the origin of the circle is from the origin of the coordinates, so square root of x squared plus y squared. So all of that is the definition of the class. And then to use it, we can construct a circle by saying circle C, right? Construct node X. So circle C makes a circle. We can call its various methods, set the radius, set the location, and then we can call some methods, area and distance, print those out, and print out fields as well. So this will make a radius 5 circle at the point 2, 3. So there's radius, distance from the center, or area, distance from the center, and radius. Alright, same class circle. It's got a radius, it's got an origin, it's got our constructor, which this time lets us construct by passing a radius and x and y coordinates for the origin. And we use the internal methods, set radius, set location, right? We can also construct with just a radius, and that sets the location of the origin to 0, 0. So multiple constructors. Okay, same thing that we saw in Java. And the rest of this is pretty similar. Well, we can make C a circle that we had in the previous example. We can make D a circle, radius 7, centered at the origin. And no big surprises there. class circle, same fields. Most of this code is the same as the last one, but the area method, we have a prototype for it. So it takes no argument, it returns a double, but we don't actually have the code for it sitting in this class definition. So the class definition ends down here. And then outside I can define double circle colon colon area, which says I want to define a method called area inside the class circle, and there's the code for it. Right, so you can split this up. And this will do exactly the same thing as the previous example. And you can have a default constructor. So if I don't specify anything, my default constructor sets the radius to 1, origin to 0. I've got a constructor where I can specify everything. I've got my area method defined outside, and so I can just say circle C, and it calls a default constructor. So there's a circle of radius 1. Anybody see the major snafu I'm doing here?
Your area's wrong.
Yeah, my area is actually my circumference. Oops. Okay, good thing we're not grading for elementary math.
Every math major in this room flips the table.
Yeah, right.
Probably no math.
All right, so here's a class called mynum. So imagine we're doing our rational number thing, but I didn't want to actually write a rational number package. But I'm just defining my own type of number called a mynum, and it has just crazy properties that I'm going to write in my code. So class mynum, it has a value which is an integer. When I construct a mynum, right, I pass it an integer, that becomes the value of the integer. And I have a single method, an operation I can perform on two mynums, which multiplies their values together. Okay, so I can construct mynum 10 for A, mynum B has got a value of 20, and I can say let's do A dot op B and find its value. And A dot op B says take the number A, which is 10, call the op method with an argument of B, which has a value of 20. That should give us a number whose value is 200. And when I print that out, I should get a 200. All right, so that's not terribly exciting, but this is. So exactly the same code, except I've changed this. Instead of being op, I've changed the name of it to operator plus. So mynum is the return type of this function called operator plus. And operator plus is a special name. And what happens is if I use the plus operator on two objects of type mynum, it's going to call my operator plus code. So I don't have to say y equals a dot operator, right? I can have a and b be mynums. I can have y be a ynum. I can just say y equals a plus b, and it'll call my code. And my plus code is actually doing multiplication because it's a weird number system, right? So even though a is 10 and b is 20, when I say y equals a plus b, y is not going to be 30, it's going to be 200, right? Because I've overridden what the plus operator does. Alright, so operator overloading is a potentially useful, potentially hazardous feature. A lot of people get upset because Java does not support operator overloading, even though it kind of does in some ways. But the plus sign in Java always means plus, right? Or concatenation. It's fixed. C++ we can change plus, minus, times, all these different operators to be basically whatever we choose. So if you were making a rational number package, right, we could call these things fractions. We could say fraction A, parentheses 10, fraction B, parentheses 2 comma 3, and then if we did A plus B, we would get a fraction that was equal to 10 2/3. Right? And it lets you sort of not have to rewrite your code just because you're using this different data type. So that's potentially useful. It makes your code cleaner. All right, so that's my 40-minute overview of C++. One of my goals in fall was to get better at C++, so I took one of my Java packages and ported it into C++. And I was hoping to speed it up, and it didn't speed up for some reason. I don't know why. Either Java is way more efficient than I thought, or there's something wrong with my C++ coding. But
I looked it up a while back, and it seems like it just depends on what you're doing, but generally C++ usually ends up being about 2 or 3 times more efficient.
yeah, it should be.
It does depend on what you're doing.
It should be faster, and if you have like a gazillion cores, that helps too. All right, so I've had a few people ask me, either because they're doing another year at Clark to finish physics, or just because summer is a long time. I've had a few people ask me ideas for keeping up with programming practice over summer, or until you get on to your next programming courses. And my advice always just comes back to write code, right? If you can find a project that you might be interested in, even if it's just something you're just going to do just for fun, not something that's necessarily going to be useful, that's probably going to be more successful than just picking out random problems and writing them, right? But make up a language and write an interpreter for it. It doesn't have to be fancy or powerful or perfect, but that's a lot of different areas to work with. Take a project that we've done and embellish it. If your SLP involved programming, right, you can obviously work on that. But the more coding you do, the better off you're going to be when you're trying to, learn new concepts and such. If there's a way you can have a daily coding practice, I strongly recommend that. Even if it's just 15 minutes a day, right? Or 5 minutes in the morning and 5 minutes at night or something. But the process of thinking about a problem, turning it into an algorithm, and then writing some code for that is just, the more you do it, it'll become more and more second nature, and that's just going to help you down the road. About 10,000 hours, right? So it's kind of a rule of thumb benchmark. How did the Beatles get to be the Beatles? 10,000 hours of practice, right? So nominally 10,000 hours to become, extremely proficient at something. So 10,000 hours of coding, right? That's a lot. But think about it. How many hours have you done? What would it take to get to 10,000 hours? When would you like to be at a point where you say, I'm extremely proficient in coding, right? And is it 15 minutes a day? Is it an hour a day? Just stuff to think about. But definitely stick with it in some way as much as you can, and don't beat yourselves up if you can't, right? Because there's other things going on. But if you find yourself in a situation where you got a few days and you got your laptop, pick up a project, come up with an idea, and make it work. And that's definitely productive. All right, I will let you out 30 seconds early. So final exam Monday, 10 o'clock, 2 o'clock. I will see you then.